Hello everybody, this is Mr. Bowman. So today we're going to be looking at a way to solve something called a system of equations. So a system is when you have more than one equation and you're trying to find a solution that will solve both of them. Okay, so what we're going to be looking at here is what are ways that that can happen. So today we're going to be looking at the graphing method, and then we have a little bit of vocabulary to look at. Okay. So the graphing method itself is a way of using what we know about lines and graphs in order to find a solution to both of them. So what we really want to remember is if we have a line, any line at all, everything on that line is considered a solution. So this would be a solution, this would be a solution, this would be a solution, this would not be a solution since it's not on the line. So we're going to use that idea in order to find a solution. So to do that, I'm going to graph both of these and see if they have any solutions in common or they overlap. So I need two colors here, I think, for this. So we'll graph this one in red and this one in blue and see what we get. So to graph this one, I'm going to start at my y-intercept of 1, and I have a slope of 3. So that means I need to go up 3, right 1 from my point. So 1, 2, 3, 1, 1, 2, 3, 1, and I can go the other direction as well to kind of stretch that out. So my line right now for my top one looks like that. Awesome. Leave that alone, and now I'm going to do my blue one. So I want to start at 8, so way up here, and have a slope of -4. So I'm going to go down 4, right 1. So down 4, 1, 2, 3, 4, right 1. Just keep going to make sure my line is complete. Okay. And then if all of these blue points are solutions and all of these red points are solutions to the red one, I'm looking for a point that solves both of them. And that would be right here where they intersect. Okay, so that intersection point is my answer. And remember, I need both points, both coordinates for it to be a solution. So this coordinates of that point is 1, 4. So that is the solution to this system. Because if I plug in 1 for x and 4 for y, it'll be true for both, which we can check. 3 times 1 is 1, plus 1 is 4, which equals 4. Here, if I do it, -4 times 1 is -4, plus 8 is +4. So we get 4 equals 4 for both of them. So if they're already in slope-intercept form, this is great. If they're not already in slope-intercept form, we need to look at it like this. So I'll need to take these are in standard form, take my standard forms and turn them into slope-intercept form before I start. So you have a little bit of practice doing that, so I won't walk you through that right now. But after you do that, let's see, we'll subtract that over. So I have y equals, let's see, subtract 3x divided by 2, so positive 3/2 x minus 5. And this one would be y equals, subtract x, so -1/2 x minus 1. Okay. So if I take each of these and graph them, once again, separately, so I just do them one at a time. So I'm going to start at -5 and have a slope of 3/2, so up 3, right 2, because they're both positive. 1, 2, 3, 1, 2, 1, 2, 3, 1, 2, etc., etc. I get this one. Okay, and this one I start at -1 here, and this is a negative on top, so down 1, but the 2 is positive, so down 1, right 2. Down 1, right 2, down 1, right 2, etc., etc. When you do yours, you'll probably have only need a couple points to get yours right, but I'm doing these by hand, so I need a few more. Okay, so now my intersection point is right here. So it looks like my answer for this one is 2, negative 2. Okay. Now, potential pitfalls of this method. Notice these don't hit perfectly. Like, it looks like my blue one's a little bit off. And I don't know if that's because I was being sloppy, or if the answer is not actually 2, negative 2. Maybe it's 2, negative 1.9. And it's really close, but not quite exact. And I can't really tell from the graphing method. So we're going to look at some other methods that'll help us find exact answers as opposed to just integer ones. Before we do that, though, we have a quick vocab we want to talk about when we're thinking about systems, because there are 3 ways that you can get a system. So the one we looked at, which is where you have your 2 lines, so that's 1. We could also have a system like this where they don't actually hit each other and they're parallel the whole time. Or last but not least, maybe we have lines that land on top of each other. Okay? So when we're referring to these, I want to explain what the words are because you're going to run into them. So this first one is known as an independent and consistent system. So independent because they are different lines, and consistent because they do run into each other at some point. So that right there. This one is independent because they're separate lines, but it's inconsistent because they never actually touch. They're going to be parallel, so they're never going to have a solution because they're not going to touch. And this one is known as a dependent system because they're actually the exact same line. The equations may look different, but they end up graphing right on top of each other, so they're actually the same line even though they're 2 different equations. So just make sure you at least have those jotted down, so if you see that terminology, you know what they're talking about.